Hello guys, hope you all are doing well. So in the continuation of the previous gate series, we are solving a question of gate 1993 and today we will solve few more questions. And after this video, one more video will come for 1993. Due to some work, I was unable to record all the questions in a single video. So without wasting time, we'll look into the questions. So what question is saying? Water flows through a 30 diameter pipe at atmospheric pressure. Pitot tube measures the velocity of water at the center of the pipe as shown in the figure. Okay, so the pitot tube measuring the velocity at the center, that means the velocity which we will calculate from the pitot tube will be below V max. Okay, whatever will be the velocity, that velocity will be V max. The pressure difference between the impact tube and the static tube is 20 centimeter of the carbon tetrachloride, density 16,000 kg per meter cube. Calculate the volumetric flow rate through the pipe in cubic meter per hour. Viscosity of water 1 centipoise and flow is laminar. Okay. So very first thing, few things to remember that very first thing, calculate the volumetric flow rate. For pitot tube, we know that V is equal to Cv root 2gh, where Cv is the coefficient of discharge, and it is 0.98 or 1. If it is not given, then we will take it as 1. Sometimes in the question it is given as 0.98, but here we will take 1 because it is not given. But with the 0.98, the answer will be alter a little bit. Okay. So H, what is H? H is stagnation pressure head minus static pressure head. Always remember. So we have here that impact tube and the static tube. That means impact tube is the stagnation pressure head. Pressure head will be unit of meter. Okay. Or it is given directly that H is 20 centimeter. Okay. This formula can be written as V is equal to Cv root 2G del P by rho. Okay. Where del P will be 1600 into G into 0.2, because it is saying that the 20 centimeter of the carbon tetrachloride. Okay, so this will be the del P, and this density will be density of flowing fluid, that is water. Okay, so both formula will give the same answer. Okay. Okay. So we have putting all the values. V is equal to 1, 2, G is 10, we have taken the gravity 10 and 0.2. Okay, so we'll get velocity 2 meter per second. This is the velocity V max. Okay, but we have to calculate the volumetric flow rate. So for volumetric flow rate, Q is equal to area into average velocity. Okay, so we will apply this formula. Okay, Q is equal to area of cross section into average velocity, right? So we have to calculate the average velocity. So for laminar flow, this is the formula. We will get U average is 1. Okay, so V average, we will get Q is equal to this, meter cube per second. We have to convert it into hour. Okay, so 1 minute 60 seconds, 1 hour 60 minute. Okay, 1 hour 60 minute. So from this minute will cancel, it will become 60 second. So 1 hour 3600 second. So we will replace second by hour, so it will become 7.0685 into 10 to the power minus 4 meter cube. We will replace second with hour into 3600. Okay, so this is the final answer. Okay, so switching over to the next question. A piece of wood floats on an interface between the layer of oil and water as shown in the figure. Okay, specific gravity of the wood and oil are 0.95 and 0.75 respectively. Determine the volume fraction of wood in water. So we have to calculate the volume fraction of wood in water. Okay, so this is water, understood automatically, and this is oil because oil is lighter than water. Okay, so height of the wood in oil will be represented by H, and the total height of the wood will be capital H. Part of wood in water will be H minus H, right? So we have to calculate H minus H upon H. Okay, we have to calculate this. Now, for these type of questions, if there is something, some stone which is partially in oil and partially in water, which is floating between the two layers or three layers in the oil, then we have this equation, complete equation. Write it down. This is the complete buoyancy force equation. Okay, rho gv, where v is the volume fraction of object in fluid 1, not the volume of object. Okay, volume fraction of the object in fluid 1, like volume of the object in the fluid 1, volume of the object in fluid 2, and volume of the object, total volume of the object. Okay, so this is the complete equation, and this equation applies for all the objects, whether it is wood, stone, any kind of thing which is in between of two layers, floating between two layers. This equation will apply. Learn it directly. Okay, so now putting all the values in this equation. Okay, so water is fluid 1. Suppose water is fluid 1, so 1000 G will cancel out. Okay, so and volume of object in fluid 1, volume of object in fluid 2, volume of the object. Now, so 1000 volume. Okay, put in the value of everything, density. Now we'll cut the zeros from here. 0 0 0. Okay, now here is volume. Area will be same, whatever in the oil or in water, area will be same, that is length into breadth, but height changes. Okay, so area will cancel out, but height changes. In water it is H minus H, as I told you, H minus H. In oil it is H, and the height of the complete object is H. So we'll solve that. Okay, so final equation will comes out like this. Now rearranging this equation, we will get volume fraction of wood in oil is 0.2, but we have to calculate the volume fraction of wood in water, so it will be 1 minus 0.2, that is 0.8. And you can write, since from this equation H is equal to 0.2H, I can write this, and I have to find this. Okay, so just H minus small h values come from this, so 0.2H upon total H, so it will give 0.8. Okay, so the same thing. Okay, so this is the question. If you have any doubt, just comment it below. Switching over to the next question. This is an example from the McCabe theory, and very good example, because it is just a similar example which GATE had asked several times, depending upon the power required and pressure developed by the pump. So we will see that question. That is very important question. In figure, a pump draws a solution of specific gravity 1.84 from a storage tank through 75 mm dia steel pipe. Okay, so we have these two pipes have the same diameter, 75 mm. Okay, the efficiency of the pump is 60%, so efficiency is equal to 0.6. Velocity in the suction line, that means this here, suction line is 0.914. The pump draws through a 50 mm diameter pipe to overhead tank. The diameter of the discharge pipe 50 mm. So the velocity will change according to A1 V1 is equal to A2 V2. This will be compound D1 square V1 is equal to D2 square V2. So we will put the value, so we will get V2 because we have V1, right? So The end of the discharge pipe is 15.2 meter above the level of the solution in the feed tank. So this is 15.2 height is given. Friction losses in the entire piping is 29.9 joule per kg. So we have HF, but HF is the head. That means this has the unit of meter, but it is 29.9 joule per kg. So we have to divide this by gravity. We have to divide this by gravity. 9.81 meter per second square. Now see, joule is what? Joule is Newton meter. Newton is what? Kg meter per second square, right? So kg and kg will cancel out, second square will cancel out, meter will cancel out, it becomes only meter. So when it is in joule per kg, you have to divide it by g. That will give the head unit. Okay, now both the tanks are open. Okay, what pressure the pump develop and the power required by the pump? Okay, so very first thing, pressure, we have to calculate the pressure the pump develop and the power required by the pump. Okay, applying Bernoulli equation. So see, very first we will calculate the pump head. So for pump head, since both the tanks are open to the atmosphere, P1 and P2 will cancel out because both the tanks are experiencing atmospheric pressure. So final equation will be like this. Okay, so putting the values, rearranging and putting the values, this equation is important. So efficiency is 60%, we have to calculate the pump head. 4.23, automatically V2 will come, and after squaring of the V2 we will get 4.23, and 0.914 is the V1, squaring that we will get 0.84. 2g, 15.2 is the height given, 29.9 divided by the g will be the head. So HP will come 30.7. Pump head. Okay, now pressure developed by the pump. Now this concept is important. Pressure developed by the pump, when it is said that the pressure developed by the pump, always remember the pressure developed by the pump only will calculate between these 2 points, very near points of the pump. Pressure developed by the pump always calculate very near points to the pump in this section only. Okay, so always remember. So applying Bernoulli equation, C. In this equation, what will be the 0? Z1 and Z2 will be equal in this portion. Since this portion is very small, head loss will not be there, will not consider the head loss. We have to calculate the P2 minus P1. Okay, we have to calculate P2 minus P1 will the ultimate pressure developed by the pump. So, okay, so P2 minus P1 divided by rho G will be equal to V2 square minus V1 square by 2G minus efficiency into pump head, right? Because this will cancel out, so we have this will be, if I take this to this side, this will become P1 minus P2, and this whole term will come in negative. So when this whole term will come in negative, then it will become P2 minus P1 by rho G is equal to efficiency into pump head minus V2 square minus V1 square by 2G. So we will get del P 329 kilonewton. Okay, 329 kilonewton. Okay, now power required by the pump. Power required by the pump is equal to rho G Q HF, where HF is the pump head. Okay, so where HF is the pump head. So power required will be equal to rho 1840 into 10 or 9.81 into Q. Q will be area into velocity. Q is equal to area into velocity. We can calculate in any of the section, either in suction or either in discharge. The Q will be same, 0.004 into 30.7, that is pump head. Okay, so it will give 2.2, 2.2, so it will come 2.2 kilowatt. Okay, so this is the, then we have left with 3 questions. I'll upload the solution as soon as possible. Okay. Okay, so that's all, guys. If you have any kind of problem or any doubt, just comment it below. I'll try to reply as soon as possible. Okay, bye guys, take care.